All right, with much energy, not. We are going to do semester review part 2 for spring 2017. All right, let's see what we got here. So, number 20 and number 21 talk about using synthetic substitution. What is synthetic substitution? Well, that's where you take the number that they tell you, like find g of 4, and you do synthetic division. So, to kind of go through that step by step, let's go here. Let's rewind. Okay, so setting up, it says find g of 4. Okay, so then we look at it and we say, okay, it says 10x to the 4th, so I write the 10. After x to the 4th, there should be an x cubed. There isn't one, so I put a 0. Then there was an x squared, negative 4, 5x, and negative 2. And basically, I go ahead and say, bring down the first number. I'm going to do the same thing for the 6, because it said g of 6 also. Multiply, add, or I'm sorry, combine, multiply, combine, multiply, combine, multiply, combine, and that final answer in that box is what g of 4 would equal to. In other words, if you put 4 in place of the x's, 4 in place of the x's, you would get an answer of 2,514. Do the same thing for the 6, negative 6, and you get a fairly large number that could be, say, I don't know, really big, like, say, 12,000 something, if you don't make a mistake in the multiplying like I did. So the final answer there should have been 12,784. And again, all you're doing there is using synthetic substitution. So, same thing for number 21. I'll go through the g of negative 7. Now notice here, it should have been x to the 5th. It starts off at x to the 5th, so I got 1 x to the 5th. There was no x to the 4th, so I put a 0. Then there was a negative 12x cubed, but there was no x squared, so I put a 0 there. Negative 6x and 8. And then I go, okay, 1, multiply, combine, 0 minus 7 is negative 7, 49, and you keep going like that. 49 minus 12 would be, say, 37. 37 times a negative 7 would be 49. Carry the 4, negative 259. And then that would be negative 259. And then you would multiply again. Okay, so this should give me 1,813. 9 times 7 is 63. Carry the 6. 35 plus 1 is 41. Carry the 4. 2 times 7 is 14. Plus 4 is 18. Okay, combine that with the 6, and you should get 1,807. Okay, and then multiply 1,807 times the 7, and that will give you 12,640. Really? We had to make these funky numbers like this? And negative, and then combine that with an 8, and you would get plus 8, negative 12,641. And I'm trying to squeeze that in. And there you go. So that should be the answers there, and, you know, that's basically how you do it. All right, moving on. Okay, factoring. Got to talk through all these really quick. Number 22, you got to do about factoring. So basically, we're trying to see how could we find all the factors. First thing you would do is go ahead and put the x minus 3, so test that out. So the opposite of a minus 3, because this is x minus 3, not in parentheses. So we're going to say 3, and then set it up to do synthetic division. You go through the synthetic division, and what you will get is a new factor. If this started out 100x cubed, well, this becomes 100x squared minus 121. And then that becomes very easy. Remember, every time you see x squared minus, you can think x plus, x minus, and what's the square root of 100? 10. What's the square root of 121? 11. And that's it. Throw in the x minus 3, and there's all your factors. Okay? And that's not very hard. You can do this one fairly simple. If you look at 23, you'll go through the same things. Do keep in mind, and you can add this to your factoring rules, that if it's x plus, like when you see here plus plus, again we're saying plus plus, think of these large numbers. When you have large numbers like this, maybe you might be able to do square roots, and then you won't have to worry about like doing some kind of crazy factoring. Because notice the square root of 36 is 6, and the square root of 169 is 13, and so that's where I'm getting the 6x plus 13 that I get to write twice. Notice that it gets to be written twice, but again, we could have followed the rules of plus plus is plus plus, minus plus would have been minus minus, but you know, still the same rules apply. Okay, now 24 and 25. I show you how to do those by factoring. So like minus minus is a plus or minus plus, and you're looking for two numbers that multiply to give you 42 and would subtract to give you 1, like 7 and 6. And then you take the opposite of that and you would say that would be the answer. Same thing for number 25, and that gives you two real answers. So you can also say that those are two real answers, real whole answers, real whatever. I just care about being real or not real. Okay, and here I've got 10 and 9, and those again also are two real answers. Now, the other way you could do this, and it's a little bit harder with number 25 because is that you could graph them, and if you graph them, you would see something like on number 24, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, and it would go through like 7 and 6, and you could do it like that. So anytime they're asking you to find the zeros, you can a lot of times just do the graph, and you might be able to get at least the real answers. Okay, so there's 24 and 25. And again, you can go back and see if you need to and pause the answers there or go to the graph. 24 and 25, let's look at 26 and 27. Describe the real zeros. That one I did graph. And so on 26, you would have to use the calculator. I've shown you how to use the calculator. And you can tell me that because we see it crossing 3 times, that is 3 real zeros. 27, I can see that it crosses 1 time. I'm giving you kind of my rough drawings for these graphs. So that means there's 1 real zero, but there's supposed to be 3 answers because it's x cubed. Remember, the exponent tells me how many answers I should have. So x cubed tells me there should be 3 answers. So there's 1 real zero and 2 imaginary, and always keep in mind imaginaries occur in pairs. So there's 2, 4, 6, like that. 27 does ask you to say find all the real zeros. So you could do synthetic division. Like you could see here that this crosses at 5, and then you could do the synthetic division to say figure out how, like, what would be the next term there afterwards, and you would get something like this. And based on the way this one's written, you would have to use quadratic formula because this is not factorable. So you would end up with something like with the quadratic formula, 7 plus or minus I. I would probably do something a little different if I can, if I get time, if I get a chance, change it up to where it might be a little bit easier. And instead of like saying like 1x squared minus 14x plus 50, maybe I give you something that would have ended up like this, where you could have said, oh, it's just x squared plus 25 equals 0, and move it over. And I'm completely making these numbers up. Keep that in mind. It's not based on the numbers that you see above you. And the square root of 25 is 5. Because it's negative, that's 5i plus or minus. Okay? But we'll see. All right. So that's 27. 28, find all the zeros of the function. Again, see where they cross. You can see, don't forget, if it turns or just kind of touches a thing, doesn't kind of cross through it, that one will count twice. So you can kind of see that. Anyways, moving on. We did omit 29 through 41, even though I just now noticed that some in the 30s I could have used, 30, 31, 32, but that's okay. Those are all kind of similar to the to what we talked about, and hopefully we'll see some other problems like that. If I don't, well then that's fine. I'll omit those. Okay, 42 square roots. I'm going to let this one play out. You should know this how to find the square roots of certain numbers. For the exponents, all you need to do is divide by 2, and you would get those exponents for those. When it's a square root, you divide by 2. If it's a root of anything else, you divide by that number. So you can get these answers like this. Okay, now look at 45. And 45 says square root of 169 x8 y4. And again, square root of 169 is 13. 8 divided by 4 is 8 divided by 2 is 4. 4 divided by 2 is 2. And there's your answer for that one. 46 does ask me the fourth root. If you press Control and then the caret key, you can always find the fourth root of a number, or you can find the nth root of any number. And so I could type into the calculator, if I don't have a table already set up, and if I don't know the answer, the fourth root of 81 would be 3. Well, let me get rid of that one. And let's see here. Go like this. 3. And then 32 divided by 4 is 8. And 20 divided by 4 is 5. And that's it for that one. Okay, so those problems you can kind of see. Okay, there's 47, and you can see the same thing. It's not that hard. What do you do when you get numbers that have to be simplified? They can't be, say, divided. Well, again, there's a couple of different ways you can do this. One is to have a squares table already built in. Okay, so like you could say 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 20. Like you can like have that written down. Remember, that's something you can add to your note page or whatever. And like you start dividing. Does 81 go into 98? No. Does 64 go into 98? No. Does 49 go into 98? Yes, 2 times. And what's the square root of 49? Well, if you have your table, or if you don't know it, it's 7. The 2 that it isn't a square root would go back inside the radical symbol, the square root symbol. 23 we could divide by 2, but we're going to get, like, say, a fraction 23 over 2. But again, calculator, there is a way, if you press Control Enter, to say get that to be a decimal, and it would tell you that it goes into it 11 times with a remainder of 1. So that means that's 1x that will be left over. And then 24 divided by 2 would give me 12, so that's why 12, and there we go. That's that answer. Same thing for 49, 25, square root of 50 is 25, and 2, and kind of go from there. Okay, if you need another way to get the exponents for, like, one that don't divide evenly, you can write out every single x. So they're saying there's 11 x's, and I can circle 5 groups of x's. That would tell me that's x to the 5, with one little x left over, so that's the one that stays inside the radical. Okay, so that's another way to approach sometimes these problems. Or you can do a prime factor tree and start breaking those up, like I'm going to do with number 50. Because on number 50, I need to make sure that before I add or subtract that I've simplified these radicals, which is what you're seeing me do, and I'm breaking them down to prime factors. Pairs go on the outside. Leftovers stay inside. So like I can break up 20 to be 5 and 4, and then I get 2 and 2, and I see I have a pair of 2's. You're only looking at the ends. I have a pair of 2's with a 5 left over. 45, I've got 5 and 9, 3 and 3, and I've got a pair of 3's with a 5 left over. So now that I know these are all forms of square root of 5, I can just add 7 plus 2 is 9, 9 minus 3 is 6, square root of 5. Notice how the square root does not change, just the numbers that are in front. Do the same thing for number 51, and you end up with, and I'm going to show you why 7 squared is, or 40, square root of 98 is 7 squared 2. So I can say this is 2, and I get 49. And then 49 is 7 and 7. So looking here, I can see I've got a pair of 7's with a 2 left over. The pair of 7's go on the outside, what the pair was. So kind of keep that in mind, and the leftover number goes inside. On this one, I can do the 8 because I want smaller numbers. 2 and 2, I can see I got a pair of 2's with a 2 left over. And on, say, this 54, I can say, oh, let's say 2 and 27. 27 is 3 and 9. And 9 is 3 and 3. So you look here, actually like that, and you can see that you got a pair of 3's. That's that. And you have a 3 and a 2 left over. So that would be, whoops, a little bit more than I wanted to do. That would be 3 squared of 6. Okay, so on the 216, you can see I just divided by 2, because that's the first thing I can see. That's 108 divided by, or 2 and 108. 108 splits up to 2 and 54. 54 splits up to 27 and 2. 27 splits up to 9 and 3, and then 3 and 3. So you got a pair of 3's and a pair of 2's. 3 times 2, because that's what each pair was. 3 times 2 was 6. And then the leftovers, 2 and 3, would be 6 also. So now I can say what's 7 plus 2, which is 9, square root of 2. And what's 6 minus 3, negative 6 plus 3, which would be negative 3 square root of 6. And that's my answer. Sorry, didn't mean to delete that. Okay, so next part. 52. How do you multiply? Well, all you got to do is make sure everything multiplies in one parentheses multiplies the other parentheses. So I'm going to say 2 times 4 is 8. 2 times square root of 7 is negative 2 square root of 7, because it was negative square root of 7. Square root of 3 times 4 is 4 square root of 3. Notice how the non-radical number is on the front and the radical is inside. On the left. On the right. And then 3 times square root of 7 just means 3 times 7, which is 21, but it's still under a square root. Then you would see if you could simplify and combine anything. In this case, no, you can't, so there you go. Let's look at 53, same thing. 4 times 6 is 24. 4 times square root of 3 is 4 square root of 3. 7 times 6 would be 6 square root of 7. And then the 3 and 7 would be 21. And again, nothing you can do with those. All right, so let's quickly try to cover into the 50s. I think these are the numbers I will do on the part 3. So I'm good for here for part 2, and I will give you a part 3 later on. Thank you very much for your time, and we'll keep going. Carry on.